In this video, I'd like to talk about the standard equation of a circle. And with deriving this equation, it's simplest to start with a circle where the center is at the origin. Now, when we want to come up with an equation for this circle, we want to consider some point on the circle. So let's just pick some random point. And this point will have coordinates x comma y. And we know that the distance from the center of the circle to a point on the edge of the circle is the radius. So we can call r the radius of the circle, and c, that's our center. Now, we want to determine the relationship between this radius and this coordinate point x comma y. So to do that, what we can recognize is that we can form a triangle here. So let's drop a vertical line, and we'll look at a line that's horizontal to that so that we can form a right triangle. Since if we have a right triangle, we can use the Pythagorean theorem. Remember that the Pythagorean theorem just says that when you have a right triangle where the legs are a and b, that when you square them and add those together, they're equal to c, which is the hypotenuse, squared. So in this case, we just need to figure out the legs of this right triangle. And notice that this height here, this is at a height of 0, and this is at a height of y. So this height of the triangle is just y. And likewise, for the x values, this starts at 0 and goes all the way to an x value of x. So this is just x here. And relating these using the Pythagorean theorem, we can call x and y, those are just a and b. So we have that x squared plus y squared is equal to the hypotenuse squared, which is r squared. And this is the equation of a circle centered at the origin. So this is the most basic equation for a circle, since the simplest one is when the center is at the origin. Now, if we want to look at a more complicated circle, where its center could be anywhere on the coordinate plane, there are two different approaches. One is that we can just shift the equation around using properties of shifting functions, or we can draw another picture. So let's take that second approach, where we have a picture of a circle somewhere on the coordinate plane. And again, we're dealing with the x, y axes here. Now, let's say that this center is at the coordinate h comma k. And why h and k? Well, those are just the letters that are typically used for the center of a circle. And that means that this x value is h, and this y value here is k. And we'll take the same approach as we did for the circle at the origin. We're going to plot some point on the edge of the circle, let's say right here, that has coordinates x comma y. And again, this could be any point on the circle. You could do this at any spot. But what we're going to do is look at the relationship between this point and, again, the radius of the circle. So let's draw in the radius. We call that r. And we can, again, make this right triangle. So let's drop a vertical line that stops at the lower y value of k, and a horizontal line that goes from the x value of x to the x value of h. And again, this will be a right angle since this is vertical and this is horizontal. So if we can figure out the lengths of the sides in this triangle, this right triangle, then we can again use the Pythagorean theorem. And this vertical length here, notice that it has a y value of y for its topmost point. And if we want to find this distance, we can just subtract k from y. Since imagine if these were numbers, if that was confusing. If this was 6 and this was 3, then we'd know this distance is just 3 between them. Or we can subtract 6 minus 3. And likewise, for the x coordinates for this horizontal side, notice that this would have an x value of x at its rightmost edge. And right here, this has an x value of h. So this distance here would just be x minus h. Since again, just think about numbers if this doesn't make sense. If this was 9 and this was 4, and it's not drawn to scale, but just imagine, then the difference between these is just 5. There are 5 units between these. Or you can take the larger one and subtract the smaller one. So x minus h, or 9 minus 4, to get 5. So we have our two side lengths, y minus k for our vertical side and x minus h for the horizontal side. And now we just want to apply the Pythagorean theorem, that a squared plus b squared is c squared, where a and b, these are the legs, so we could plug those in. We have that x minus h, we square that, that's our a value, and then we add that to our b value squared, so y minus k squared, and this is all equal to the hypotenuse squared, and our hypotenuse is the radius, r. So this is equal to r squared. And this equation here is the most general standard equation for a circle, where, again, r is the radius of this circle, and its center is at h comma k. So it might be helpful to see an example of this. Let's say that we have the equation x minus 2 squared plus y plus 3 squared is 16. Now, we know that this is equal to the radius squared. So this right here is the radius squared. If we want, we can even write that as 4 squared. And you can see right away that r, the radius, is equal to 4. And its center is at h comma k. So one way to think about it is the x value of the center is the x value that makes this expression 0. So it looks to be positive 2 in this case. Or another way to think about it is that you're subtracting h. And in this case, you're subtracting 2, so that means that h is positive 2. Now, for the y values, you are subtracting k, but in this case, you're actually adding 3. But this is the same thing as subtracting negative 3. So the y value of the center, k, is negative 3. And the other way to look at that is think about which y value makes this expression 0. That would be negative 3 in this case. So the center of this circle has an x value of 2 and a y value of minus 3.